talked yesterday about الهاف adder والفول adder وحكينا انه الهاف adder هو اللي يعمل الاديشن متاع two binary like 0 plus 0. When we add two binary 0 plus 0, it will give us 0. This will be saved in S. However, if we will make the sum of, for example, 1 plus 1, we will have 0 and a carry of 1. This carry will be saved in C. That's why in the half adder we will need S and C in the output. 0 plus 0 is 0, the carry is 0, and 1 plus 1 is 0, and we carry 1. This when we want to add only bit plus bit. And we said also that we can create this half adder physically يعني using logic gates. half adder هذايا باش نخرجوا الاس لاحظنا انه it is the same pattern as the XOR, so we can use the XOR gate in the circuit. This is the circuit for the half adder. And for the carry, we can use the AND gate because the pattern is AND 0, 0, 0, 1. It is 1 only when both are 1, so we can use the AND gate to design the outputs. هذاك علاش حطينا ال AND gate لهنا باش نخرجوا الكاري. With these two components, we can create half adder. In the computer, there are millions of half adders. The half adder is not useful because we don't add only bit plus bit. Usually we add byte plus byte, word plus word, etc. That's why we need a full adder. The full adder is a combination of many half adders. This is the circuit for the full adder. This is a half adder, and this is another half adder. We can add OR gate between them to find the carry, and with two half adders and OR gate we can design a full adder. Of course, we can design the full adder and the half adder using many other logic gates, not only the XOR and AND. We can, for example, design it using many NAND gates. كيف هذا? This is the preferred circuit for the in the industry because they can use only one type of gates to construct many possible outputs. Okay, this is what we finished yesterday. We started also the SR. For the SR, we said that there are two types of circuit: combinational circuit and sequential circuit. Combination circuit هو اللي what we did in AS level when inputs are combined using logic gates to produce 0 and 1. Now in this year we will use the sequential circuit when the output depends not only on the inputs but also on the previous stored output, the past state. Sequential circuits can remember bits. They are used for storage elements when we want to store the status of one bit. like the case for registers and counter. We can make a collection of flip-flops, many flip-flop cells. Each one of them is storing 1 bit. So we can construct larger memories can be used in the registers and the RAM. There are many types of flip-flops. Two of them are included in your syllabus. The first one is the SR flip-flop. You will understand now SR flip-flop. يسميه زي latch. It is a 1 bit memory element. It can be built from two NOR gates وإلا two cross-coupled NAND gates. Cross-coupled هذه means that the output of one will be the input of the other. هذوما two NOR gates. الاوتبوت نتاع الاولى ترجع للانبوت نتاع الثانيه والاوتبوت نتاع الثانيه ترجع للانبوت نتاع الاولى. This is mandatory to store the previous status in this circuit. This is a 1 bit memory based on the input and the output of the previous state. هاكا ترجع لهنا. So the input are S and R and the output are Q and Q bar. Let me explain this. This needs some explanation how it works. Behave. Let me start from the truth table. I added an analogy explanation to make it easier for you. When imagine this is the action. يعني we will turn on the lights. This turn off the lights. This is the initial state of the light. This is the final state of the light. If the light is like this, 1, 0, means it is on. And we will not do anything. We will not turn on and we will not turn off the light. What we will do, the final state will stay as it is. كانت تشعل، ما عملنا شيء، قاعدة تشعل. Imagine إذا كان هي تشعل واحنا شو عملنا لهنا؟ شعلناه خاطرها 1 0 turn on قلنا 1 is turn on شعلناه. هي تشعل واحنا شعلناه شنو يصير؟ تقعد تشعل. هي تشعل واحنا طفيناه تطفي. هي طافية واحنا ما عملنا حتى شيء تقعد طافية. هي طافية واحنا شعلناه باش تشعل. هي طافية واحنا طفيناه باش تقعد طافية. الكيس هذه 1 1 cannot happen. This is invalid state. خاطر we cannot turn on and turn off the light at the same time. So this is against the logic of the SR. أنا كتبت لكم هنا كل شيء الانالوجي اللي كنت نحكي فيها كتبتها. The output depends. Okay, بالانالوجي هذه اللي عملتها لكم you can understand in easy way how the SR works, but this analogy is not to be put in the exam. It is for you to understand how it works. Now you can understand easily this circuit. Let's take an example. Let's apply it. For example, let's take any situation. For example, let's start with this. Q is 1, Q bar is 0. So Q is 1, 0, and this is a 0, 0. This is 0 and 0. what will happen here? The state will change or not. Let's follow the circuit. This is a 1. Since this is a 1, so this 1 will go here, and we will have a 1 here. Since this is a 0, the 0 will go here, and we will have a 0 here. Let's apply 0. This is an OR gate. OR gate هو always 1 except uh, when it is 0 0, it will be 1. So the NOR gate will be the opposite. Everything is يعني this will be everything will be 1 1 1 except uh, الفلتة بعد. Okay, the OR gates 0 0 1 1 0 1 0 1 A B. This is the OR gate. The OR gate تعطينا كل 1 1 1 except the first one is 0. The NOR gate is the opposite. So it will be 1 0 0 0. So if we find the 0 0, we make it 1. We found the 0 0 here, and we will make it 1. And we found 1 0 here, 1 0 here. It will be 0. So it will stay as it is. Is it the case? Yes, it is the case. Okay, let's try another example where the state will be changed. For example, let's take this example. The S is 1 and Q bar is 1. S is 1, Q bar is 1. So this is a 0 and a 0. And let's start. Here we will take this 0 and fill it here. This will be 0. And we will take this 1 and fill it here. This will be 1. Accordingly, we will have 0 nor 1, 0 nor 1, which is a 0, and a 0 nor 1, which is a 0. This case, here we have 0 and 0. This is not stable states. Yani impossible to happen. We cannot stay here. The system will not stay here. The circuit will not stay here. This is not stable. The circuit will continue to feed the 0 here and the 0 here. This will be 0 this time. 0 nor 0 is 1. This time we will have 1. 0 nor 1 is 0. This time we will have ايش قلنا احنا yes, this time we will have 0 0 1 0 1 0. This will be 0. This is stable state. Stable means even if we repeat feeding one more time, like again 1 1 nor 1 will stay 0. And even if we feed this one more time, قلنا احنا this is 1 1 will stay 1. So the stable state is 1 0. After 1 0, after we get 1 0, even it will not be changed anymore. This is a stable state. So the 1 0 is the required one, which is here in the final state. If you repeat this here, 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 whatever, you will find the state you can find. So now you can find the state from the logic circuit, and you can find the state from the analogy. I am doing all of this to not memorize. ما نحبكمش تحفظوا ال truth table كيما هو. You can find the truth table خاطر في many past paper exercises they gave like the input and they asked you to determine the output. You can determine the output based on the logic. You can determine the output based on applying the input in the logic circuits. هذا شنو باش نفهم بالنسبة لل SR flip flop. شنو عندنا آخر؟ this is a memory storage على خاطر it maintains storage for one bit, two state devices, protection from invalid states. هذا الكل حكينا فيه. there is an alternative NAND gate circuit for the SR flip flop. كيف هذا بالضبط؟ هكا وهكا. فقط the one difference is that the S is here and the R is here. Because the SR flip-flop retains a 1 or 0 until a change is requested, it can be used as a basic building block for memory circuits. يعني احنا the main purpose نتاع هذا الكل هو شنو نحبوا نعمل؟ ونعملوا memory بلاصة نسجلوا فيها data، نسجلوا فيها 0 وإلا 1 forever. كيفاش عملنا؟ عملنا circuit اللي هي باش تخرج لنا 1 0 and this will stay forever until we set it to 1 والا reset it to 1. يعني reset it معناها باش ردها كما كنا نحكيه توا. The weakness of this design is that the combination S1 R1 is forbidden. We cannot turn on and turn off the light at the same time. This is impossible in SR flip-flop. Another thing that is a weakness is that when we try to force both Q and Q bar to 0 at the same time, we can't. No. شنو هي second one? This is the second one. If S and R change very close together in time, small timing difference can make the final stored state unstable or unpredictable. يعني فما risk متاع انه هذه تجي قبل هذه وتعطينا instability وحاجات هكايا. In the next section, we will suggest another flip-flop that overcomes this weakness. The other flip-flop is JK. It is easier, it is simpler, it is better in terms of overcoming these two drawbacks. It is like نمشي direct نفهمكم من هنا. This is the circuit. It is the same the SR flip-flop. This is the SR plus two NAND gates. NAND جديدة لهنا ونAND جديدة لهنا والقديم هو نفسه. Plus new clock, new input. Now the new thing is that we have two inputs اللي هو كانوا قبل SR only. Now بدلنا اساميهم ولات JK وزدناها one clock. Why? The behavior will be like this. We will have only three inputs. If J and K are 0 and the clock is 1 معناها 0 0 1 as inputs. Q rest unchanged. إذا كان هي 1 0 باش تقعد 1 0. إذا كان هي 0 1 باش تقعد 0 1 unchanged. If J is 1 1 is set. إذا كان J is 1 and K is 0. Again, always the edge, the clock should be always 1 so the system can work. It is about synchronization to avoid the problem of small timing difference. This is a problem in the SR design. We can overcome this problem using a clock. So all changements in the state are subject to input 1 in the clock. إذا كان J1 نعملوا لها set. إذا كان K1 نعملوا لها reset نحطوها 0. إذا كان both 1 1. Now this is the second overcome Q toggles. toggles يعني كانها هي 1 0 باش تولي 0 1 وكان هي 0 1 باش تولي 1 0. So two new things here. The first one is the inclusion of clock to avoid the problem of timing and the inclusion of a new 1 1 state. This time this is possible, not like the SR flip-flop.